I'm a geospecialist. I consider myself a young innovator because I love to innovate. I love to come up with ideas and I love to build them. And one of the products I've built and still currently building is Spatialnode. And also I'm a GIS consultant for Integration, Energy and Environment, which is a German-based company where I render GIS services for electrification planning. And then I'm a co-host of the Africa Geocoding podcast, 2020 as Young Scholar awardee for Nigeria. I love playing table tennis while I'm not on my computer, and I also love dancing. So today we are going to be delving into geocoding, which is a very important concept that is used in a lot of products that we carry around. And the underlying concept or the underlying mechanism is powered by GIS with a bit of software development. So the purpose of this workshop is to show us how we can achieve something like that for personal use or for using maybe as a startup, because there are also startups that focus solely on geocoding. In fact, most SaaS platforms, most of the big guys, they have a geocoding component in their company, which they also charge people for. And the purpose of this workshop is to show you how you can build your own geocoding system in-house, or just be like a pure geocoding startup. And it's going to be very interactive. So I'll be demoing the steps, and I hope we enjoy it. So before we go into the technical part, it's important to understand what geocoding is, especially for those that don't have a GIS background. So geocoding, or simply address geocoding, is the process of taking a text, just like addresses. You know, when you say you have an address, say for example your own address, number X, so street in a particular state or in a particular country, you know, taking that address that is in text, which is high level, which is what we can understand, and then converting that text into coordinates, which is what a GIS can understand. So the text is what we understand. We are humans, we understand addresses. When they give you an address, you know what it means, right? But the computer does not understand us. That's actually the GIS environment does not understand that. So the concept of geocoding is to convert that address, which can be a name of a place or a description of a location, and then to convert it into coordinates in forms of latitude and longitude, so that it can identify the position on anywhere on the Earth's surface. And the GIF on the right side is just demoing how one of the popular products uses geocoding, because on the GIF I was trying to check for the location of Transcorp Hilton, which is a hotel in Abuja. And what I just need to type is Transcorp Hilton, and then I could see a lot of suggestions, right? And when I click on one, it's going to take me to the location in Abuja. So, and geocoding has a lot of parts. One of them is, there are two majorly, which is single geocoding and batch geocoding. It's just more like the process or how you use the geocoding tool. So when it's a single geocoding, is just what this GIF is representing. I'm trying to search for a single address, so I'll type it, and then I will see the suggestions, and I'll see the result as well on the map. And that can also be for any other products you're trying to build. But and some more common examples are even the one we use on our day-to-day activities. For example, Uber, Bolt, even Jumia Food. When you're trying to put in your delivery address, also Bolt when you're trying to order for a ride. The same thing with Uber. So they are very common because that's what is usually what most users use, what they give to the customers. Because you know, just want to get an information about an address, so they just type it and then you see it. But batch geocoding is mostly used when you're working on research projects where you, or even, for example, customer verification system in banks where they have list of addresses of customers to verify. So The difference is just that when you are trying to batch your code, that means you have multiple addresses to convert to coordinates. So an example is bank trying to verify their customer addresses, and it can also be used for research process or research work. Say for example, you administer a questionnaire, and assuming you don't have a GIS background, those that administer questionnaire without GIS background, they most likely store the address in words or in text. And then they come to you as a GIS person and they want to understand or derive insight from this address. And then they give you a list of CSVs with text addresses. The first thing as a GIS person is you have to convert those addresses into coordinates before you can be able to analyze them and then visualize them. So in that case, you'll be doing batch geocoding. You'll be trying to automate the process of converting multiple addresses into coordinates. So that's just like the parts, or more like the approach on how to use it. So the main, to better put, the main types of geocoding is forward geocoding and reverse geocoding. So when you are trying to geocode an address, convert it from text to coordinates, that's forward geocoding. You have the high-level text, which is what we understand as humans, and then you want to convert it to coordinates, which is what GIS understand or GIS software understand. So that's forward geocoding. And you can see on this table where you have address, and then you're trying to convert it from to long and altitude, and sometimes even elevation. So that's forward geocoding. Then the second one is the reverse geocoding, and that's like the inverse of forward geocoding, just when you have coordinates and you're trying to convert it to addresses. And it's also possible, for example, in my current line of work in the electrification industry, energy industry, developers, those that install mini grids in settlements, they go to those settlements to for recognizer survey and stuff like that. So they usually collect the coordinates of those settlements. And for it to make sense, maybe for using reports, you can just put the coordinates alone. You may want to put the address and then provide some information about the coordinates. Okay, this is a settlement that is located in XXX community in a particular state, in a particular city, in a particular zone in Nigeria. So they have the coordinates, which is like the low level or the pyramid data they got on the site. Then they want to convert it into address. So converting that raw coordinate, which is long and lat, which is something you can get from a GPS or handheld devices or from anyone, converting that long and lat into text back for us to understand, right, is reverse geocoding. So it's just inverse. The forward is when you have the addresses and you're trying to convert it to coordinates using a GIS. And then the reverse is you having the coordinates and then trying to convert it back to text to address. So those are like the two types of geocoding that we have. So just to stress again, there are a lot of applications of geocoding. This is just a few of them. Health is one of them. Thankfully, if you have attended the session by Zipline, she mentioned about them using GPS to orient the drone, to know the current location of the drone and stuff like that. So it's one of the applications of geocoding. And then banking and finance, the one I mentioned earlier about the customer address verification system for public safety, military. In fact, military heavily use geocoding because they deal with high precision when it comes to coordinates. And then in commercials, Volt is an example of a commercial product. Uber is an example of a commercial product. Google Maps as well. And all these products, they use geocoding. In fact, last week I was trying to even use a platform for shipping goods from one place to another. And in one of the forms I was asked to fill, I was asked to fill in my address. And when I was typing the address, I started seeing suggestions. And I know that is powered by geocoding. So, and of course, they use Google because it's like the most popular one out there. But for this session, I'll be showing you how you can also build your own and how you can maybe compete with Google in the nearest future using open source tools, of course. So let's go into a bit of more technical part of geocoding. So this is how geocoding works under the hood at the simplest level. So you have the two main components, the reference data and the algorithm. So, the geocoding is trying to convert address into coordinates and sometimes coordinate into address. So you may be thinking, how does it work? And it's simple. There needs to be a database that has reference data of all the addresses in the world. Maybe not all, if you're not focusing on the world. If you're focusing on the single states, you need to have all the addresses, all the likely addresses of that state on the database with their coordinate and everything. So that's the reference data. Then the algorithm is now the one that will do the matching for you. So this is how the algorithm works. When you input your address or coordinates into the searching system, right, the address is classified into two. If it makes sense to the system, that is, if you input something like number 87 so street, particular state or a particular region, that's like a proper address, right? So that's like an absolute address. It's specific. But when you put an address like the building in front of ShopRite, as you can see here, it's a very good address, but it doesn't really make sense to the system. So it's usually ignored those kind of addresses, unless it could, derive some reasonable text from what you just imputed. So those are like the two ways it's classified. Then after it's done with the classification, it has figured out that, okay, this address is absolute or relative. Then it normalizes the address. And this process is just like segmenting the address and splitting it, if that makes sense. So you have number something, so state, so country. So this algorithm will normalize it, that it splits the first part and gets the zip code, if it has zip code, split it again, get the state, if it has state, check it again, get the country, just split it into different categories. So in the US, they have different address system. In Nigeria, we have different address system. So depending on the country, that's what informs the algorithm that normalizes the address. So it's just split into those different categories and then check it with what we have on the database. So if it matches anyone, it's responding to the front end. It can match a lot of results, right? Because some address are similar. And then it also ranks them and then respond with all of them sometimes. That's why if you notice, if you're typing something on the geocoding or on the search box, you see a lot of suggestions. Because as you're typing, those texts that you're typing are matching with a lot of addresses in the database. So it suggests everything for you to pick. So then it returns the results if it's finds any, and otherwise it returns none. So this is just like a simple schematic flow of how the geocoding system works under the hood. And all this reference data is stored in the database, while the algorithm is what happens also in the database and sometimes via an API, depends on how you want to build your geocoding system. But it's recommended to use SQL functions and SQL scripts and algorithms because it's very close to the data. And looking at the fact that you have database filled with millions of rows of addresses, if you want to get a very fast response, people usually put the SQL script and functions that does the matching in the database to run, which is also the same as putting it in front of an API, but it's just that most of the SQL scripts that does the whole stuff are in the database as functions. So we want to build something like I just described earlier using open source tools. And one of the tools that has done the heavy lifting of this system and algorithm for us is Nominatim, which is powered by OpenStreetMap data. I mentioned that before you say you want to do geocoding, you need to have a database filled with addresses, right, and information. And it's something that's already exists on OSM, right? Because on OSM, we have data about everything, about most things, which is also constantly updating. So Google also have their own database, of course, but because you don't have access to Google's database, you need to look for alternatives. And one of the alternatives is OpenStreetMap, which has data of everything, even beyond addresses. It has buildings and places and relations and stuff like that. So now so I prepared this slide in a way that you can follow these URLs, and that's what I will do right now. Let me just copy this URL and then show you the interface of nominatim so you can see what it looks like. So this is the interface of nominatim. You can do geocoding here. And like I said, it works with OSM data under the hood. So it's like always updated constantly. If you check here, you will see that it was updated 33 seconds ago. So it's always updated constantly. And then let's try and search for a simple address. I don't know if somebody can just drop me an address on the chat so you can search for it here and see if it's going to work. Any reasonable address or any valid address on the chat, please. Okay, I'm waiting. All right, thanks, David. I hope this address will be on the database. Unfortunately, your address is not on the database, so there are a lot of reasons that this might. Let me try to. Okay, it's not. Okay, so I think that works. All right, so this is an example of geocoding. That's what we just did. Okay, so because of time, let me just proceed with this Spatialnode gate. So this is what just happened is this address is checked with the database of OSM data, and then it returns the results and it shows it on the map. So you want to see what's happening under the hood, you expand this. If you want to apply more guides, you can also check the API requests, debug outputs if you are the net type to see what is actually coming from the database, the results and the queries that is being sent to SQL, the ranking under the hood, number of times footer appeared in the database, the algorithms on everything, how the whole system segregates the address, how it normalizes it, and how it ranks it. You can, if you are the net type, you can check also the SQL functions that was used and everything. You can check that when you click on this debug output for you to see how it looks like. So that this is nominating public API, and it's something that you can also use in your products. You can also use in your products, and let me show you why we want to build our own. So if you're building a very simple product, you can just use it very simple. If you just want to build a front end that doesn't expect much request or much users, just use this nominating API. Documentation is easy to follow. Let me see if I can pull that up. It's just nominating.org. So this is the public interface, and there's a documentation here where you can see how to use the API. So it's very, very simple. But because most times when you're building an application, you always want on the fly suggestions, in the sense that when people are typing, they are seeing the results. So that's why I want to build up, because one of their usage policies is that if you are using their API, don't do asynchronous query, in the sense that when someone is trying to search for something, don't show them suggestions. Let them type everything finished. Then when they press enter or something, before you show them suggestions. And that's what you can see that they even implemented in their own public interface, in the sense that as I was typing Spatialnode gates, I wasn't seeing any suggestions. It's when I finished with the query, then I typed search before I was able to see the results. But this doesn't have, this is not really from the user perspective, or maybe from even the popular products out there. As you start typing something on the search bar, immediately you type about 2 words or 2 letters, 2 alphabets, you start seeing suggestions of likely results. And that gives a better user experience than having to type everything before you now click on the search button. So that's why it's better to build your own in-house, which you can use to undo that kind of use case. And the reason is because when you're trying to do asynchronous queries, you're going to be eating the server as the user is typing. And that will lead to a lot of server resources for them, given the fact that it's a public API that is not used by you alone, by millions of people over the world. So they're trying to limit that to save themselves server cost. And if you go against this policy, they will block the IP address of your user, and that can throw bugs to your users, the IP address of your server, rather, and that can lead to bug on your application. So it's better to just, in fact, they recommend it, if you go to the website themselves, they recommend to just deploy your own if you don't want to, if you want to, you can say install your own in case you want to, in case you have like a different use case for the API. And that way you have like more control on what the API can be used for. And even though you give access to it, because if you deploy a geocoding system, you can also restrict access and sell this to people as well, because a lot of companies just does that alone. So this is the architecture of Nominatim. You can of course confirm this as well on their website. It has a Postgres database to store all the OSM data that exists. So it's called Planet OSM. So all the Planet OSM data is stored on the database, and they use some scripts to do the integration and the updates. And one of the tools they use is the OSM to PGSQL. So it's a command line so that they use to convert OSM data to store it in the database. So, and then they have a lot of algorithms with SQL functions that does the address computation, the indexing, the ranking, the normalization and standardization and everything. Bunch of SQL functions and algorithms. And then they have an endpoint, which is where you actually hit to query for an address. So they wrote down in PHP, and the endpoint has several routes. It has routes for forward geocoding. It has routes for reverse geocoding. It also has a route for you to check the status of your server. So that's a lot of routes, which I'll be showing us as we proceed. So for this demo, one of the tools we'll be using would be within the server, of course, because we want to deploy it somewhere. So within the server, and then we are going to be using Nominatim, and we're going to be using deploying it custom. So there are two ways to deploy Nominatim. You can deploy it like by following the documentation here, step by step, install the necessary tools on your server, and then you get it working in no time. And then there's also a faster way, which is using a Docker image. So that one is platform independent. It can work on any server platform. So it's a Docker image. And that's what we're going to be using, which is this URL right here. And then after we are done deploying it, we need to set up a reverse proxy so that it can have HTTPS and be a secured website. So for the Docker image, you can just click on this URL here to open the repository that we're going to be using. So these guys, MediaGIS, have developed an open source working container for Nominatim. Basically, all the steps that we are supposed to follow on the Nominatim documentation has been, put together in a Docker container that we can install. And this is the repository which is on the slide. So you can just come here, give it a star, and also read about documentation as well. So let's proceed. I have the steps here. So for the server, we are going to be using DigitalOcean. You can feel free to use any server you want to use. You can use AWS. You can use Heroku. You can use any PaaS, any platform as a service. You can use AWS, Heroku, Python anywhere, DigitalOcean, Linode, just anyone basically. But I want to use your DigitalOcean because I have some free credits there to demo it. But feel free to use any server you want to use. And I have my DigitalOcean already opened here. So this is not a DigitalOcean workshop, so I'll just run through the process of creating a droplet. So let's create a new droplet that's going to act as our server. So droplets are just like virtual servers, which is more like another computer that is in another part of the world. And the part of the world I want the computer to be can be decided by myself. And that's why we have regions here. So you can select the regions where you want that computer to be. And this is usually recommended to be very close to your users, in the sense that if what you're building, like this geocoding service, is servicing your users in San Francisco or in the North America zones, you can just select any of these countries. If it's servicing users in Europe, you can select any of these. So depending on where your users are, just select the region. But this is a demo, so I just select any random region. Unfortunately, there's no Africa region here. But if you're using AWS, for example, I think there's a data center in South Africa. So you can probably install yours there in case you're trying to build this for Africa customers. So this is where we select the OS you want to use. I usually use Ubuntu, but feel free to use any Linux image you want to use. And then the version as well. So because this is a demo, well, I can go ahead with using this capacities, using a server with this capacity, but it's a demo. So let me just use this. So depending on your skill, if you're trying to build a geocoding system for the whole world, of course, you need to use some advanced, some servers with high capacities. But because I'll basically be following the instructions on the documentation, and the address they use is for, I think, a country in, let me just show it to us. So they are using this for just a country in Monaco, yeah, in Europe. So it's a very small data on OSM. So I don't think we need much server resource for that. So you can just select anyone, and you can also delete it after you are done anyways. So you have nothing to worry about. Okay, then I use SSH. So you can set that up. So then you create the dopplet. So this is up to you, but what we need is just a server. And this can be done anywhere. And then when we are done setting up the server, you're going to SSH into the server, and then you can proceed with the step. So we just did this, which is to create a droplet. So yours can be to create a server on AWS, that will be an EC2 instance. And yours can be to create maybe apps in DigitalOcean or in Heroku. So when we are done creating the server, then you SSH into the server. So I usually SSH from my own VS Code. Yours can be with PuTTY, or if you are using Linux, you can just do it easily from your console. So while the server is creating, I have my console already opened, and this is where I'm going to connect to the server. So I need the IP address of the server so I can be able to connect to it from my console. And the IP, okay, still provisioning the server, so no IP address. Okay, it's done. So this is the IP address, the IPv4. So I can just copy this, and then I paste this here, and I press enter. So because I've set up SSH on my Windows that I used to connect to any servers, it skips some steps. And one of the steps is me trying to connect securely, which is setting up SSH and passing the key phrase and everything. But I've done that already. And you can see we are now on the server, which is Ubuntu. And this is the memory usage, 77.39 gig, which is something that is close to 50 gig, if you notice. And so many other things. So I can just clear this. So now we're on the server. So let's go back to the instructions. So after you are done connecting to the server, you need to create a new user and give super user privilege. So I have the command that you can run here. I also provide a link that you can use to check the tutorial on DigitalOcean blog on how to do that. So let's just use the command. The reason for this is because you don't want to install your system for security. Actually, that's why you have to create a new user. You don't want to install your system on the root So in case they hack your routes, which doesn't usually occur because we're going to set up a firewall, but in case anything just goes wrong, you still have your main application secured and protected. So we add a new user, and I'm giving it a name called nominating. And then when you press enter, it's going to ask for the password. So give the password nominating, but of course, your password must be very simple. And full name, and so that is up to you. And then when you're done with that, then we grant this user privilege so that you can be able to simple Linux commands that you're probably familiar with already. So let me just run the so you can copy and paste commands actually. Sorry about that. Okay, so the next one is to enable firewall. So this step you can see, just follow it and you shouldn't experience, and you can confirm that it has been enabled by checking the status again, and then you see the open SSH that we just added. So that's the first. Then you can log in as a root, then switch to your user that you just created, which is nominating. And you can do that by just typing SU, which is switch user, to nominating. So immediately you do that, you see it has changed to nominating from root. So now you can do anything you want to do in this nominating user without affecting your root. So that's just like the basic initial step, which you can also skip anyways. And then the next is now to install Docker, which the steps are also here. So I have a README here where I put all the commands needed because it's a lot of commands. So I'll be pushing this to GitHub. So this is the commands to install Docker. So let me just copy that and let's go through it together. Okay, so the first is to, of course, update your instance. Then it's going to ask you for the password for nominating. And the password is also nominating, which is what we created earlier. And if you notice, and I use sudo command because I've given access to use sudo for this nominating user that I just created. So the rest, you can just be copying and pasting the codes. So these are just to install Docker on this machine because we want to use Docker container to install the system. It's recently it's advised to use Docker containers than just installing your application on bare servers. So with Docker containers, you can be able to share your application, and it's just so easy to install on any server. Currently, we are using a Windows server, or a Linux server rather, but in case you have a Windows server, you can also be able to install it with the same Docker container, just some minor changes and tweaks. So that's about Docker installation. Just follow the step, just copy and paste all the codes and you should be good. So then the next is to clone the repository, which is this one I showed us earlier, this repository right here. And the command is also here as well for you to copy. So you can see now, this is just to check if Docker is working fine and then Docker is active and running. So for those that don't know Docker, Docker is more like a container system. Of course, it's more than that, but think of Docker as a pack where in that pack, you have your applications and everything that your application needs to run. Say, for example, you have a website, HTML, CSS, and JavaScript. So think of Docker as a folder where you put all those files and all the tools that it needs to run. For example, for JavaScript, you might probably need Node. Just think of it like that. It's more advanced than that, but this class is not, this workshop is not for Docker, so I don't really want to go into Docker details. So it's time for us to clone the repo, but usually what I like to do is to create a new folder where I want to install my applications. So let's just change the directory into the home folder, and then let's clone it into this home folder so that we can, yeah. So this is just cloning, and then when we check the directory now, we can see that there's now nominatim Docker there. So then we can cd into the nominatim Docker to see everything that is there. And if you notice, we have all these codes, which is something that also we have here. The same thing basically. So what we just did is just to clone this repository, because these guys have different versions of nominatim and updates. So you can enter any version you want to use. And the one I want to use is the 4.1, which is the latest. So I can just change directory, which is cd, into 4.1. And if I click on ls, which is list, I'll see all the files in that 4.1, which is also the same thing that you will see if you come to 4.1 here, everything. So then we have to run this command to start up the system. So just to show you how easy and how interesting this can be. So just paste this command and then press enter. Okay, I'm going to type. So let me be sure I typed that correctly. So just to also show that this data is coming from OSM, as you can see here. And let me just click on this. So this URL, it leads to GeoFabric, which is like a popular website where you can download OSM data. And you can see this Europe is something that you can edit. So for example, if you want to focus on Africa, you just type Africa, and then you change this to Africa as well, or to any country in Africa, say Nigeria. That's if you want to focus your geocoding system to only work for a particular country or a particular continent. So, but because it's a very large data set, because the last time I worked in Nigeria, it took about 4 hours or 3 hours for me to install and everything. So that's why I want to just go with this simple settings, or this simple code from the repository to run to start the server. So I think I'm not typing this correctly, so I'll just show. Oh, no, there should be that line there. So great, please. So yeah, where the code was coming from. So let's see if this will work now. Okay, fine. So the first thing, because the Docker container, or a Docker image rather, is going to pull the image from the public repo. So that's what it's currently doing. It's pulling this image, more like pulling that folder or that container where all the information or all the scripts, all the codes and everything needed to run the nominatim is stored. So it's pulling it. And then after it's pulled the image, it's going to download the OSM data for this country from this URL. So GeoFabric is, let me just copy this and show us how GeoFabric looks like, because it's something that can also work without you necessarily running it on a command line like this. Like it also has like a user interface. So this is the user interface, and you can go there and then click on downloads for you to see that there are a lot of, this is where they extract, and this guy stores extract of OSM data for all the continents, for the planets, and even at country level and even at state level. So while that is loading, if you notice here, you can see the ranking stuff is working now. So as the data is coming from OSM, it's ranking them and storing them in the database, as you can see here. So it's also going to index them, of course, to make the queries fast. And then there's the database that it's creating. It's going to import it using the OSM to PGSQL, like I mentioned earlier. It's going to process the data sets. So OSM data comes in node, ways, and relation. It's going to process everything. It's going to create a table for functions or partitions. It's going to import some even data from Wikipedia. You understand? And then it's going to index everything so that the queries can be fast. It's going to rank it as well. It's going to rank everything in your database. And then when it's done, so it's still working, it's still trying to finish your process. So let's wait for it. But when it's done with the process, how you know that your API is ready is by testing it, and then you can test it. For now, at this point, you can only test with the IP, and then you can copy your IP from this DigitalOcean, and you can go to this IP address to see if anything is going to show up. So if nothing is showing up, that means it's still working, it's not done yet. So let's wait for it for some seconds and then come back to it again. Okay, so yeah, it's not working yet. So if you are trying to do for the whole planet, for example, this can take weeks. You're trying to do for example, like I said, I did for Nigeria and it took about some hours. So it depends on your skill. It can take a lot of time. So why that is working, because most times you don't want to assign an IP address to your system. So you usually want to use a domain name. So I have set up a simple domain on this website. I got a .tech domain, simple geocoding.tech. And what I'll be doing now is to create an A record to point to this IP address so that when I go to that simple.tech.geocoding, then it's more or less like me interacting with this IP address. So in case you can use any domain anyways, but it's still the same process. You create an A record. Again, the step is also here. You're supposed to be testing this right now, but the server is still, and the process is still working. So, and because the next thing to do is to actually do this domain thing. So let's just go ahead and start the domain process while this completes the installation. So let's create our A record to point to this IP address. So the so HTML. Okay, so it's still working. So this. So just leave the script is going to run and work. So I'm trying to access my DNS provider so I can be able to point that simple tech domain to this IP address, because that way we can be able to enable SSL. You can't enable SSL with IP address. It's going to be insecure. So you want to see that padlock key with an IP address. And that's why we need to forward any request going to this IP address to that simple tech or simple geocoding.tech. So I'm now on the control panel of my domain provider. Still coming up. Yours can be different, yours can be name cheap, but it's the same process. It's an A record that you're just going to create and then forward to the IP address. So it's still coming up. Let's just wait for it for a while. So this has also started the Apache server. So this, in the Docker container, there's also an Apache server there. And I think that's why it's handling the HTTP request. So, so let me even reload this. Since the Apache server is started, let's see if it's working already. Because once this is up, you should see a response from the server. I think it's not up yet, so let's proceed with the DNS. Okay, perfect. So what you just need to do is to add a record. Yeah, which is this. Add a record. And then the host name would be whatever you want to name it. Maybe if you want to use a subdomain, or I think I'm okay at leaving it like this. So then the IP address, put it here, and then you click on add record. Of course, IP address should not have HTTP. Let me just go back and copy that IP address right here. And then I paste it here. So that should work hopefully. So I think this is what we just added right here. Yes, I think so. So this is the one that I added on the 6th of this month. So let me just delete that to avoid confusion. So yeah, here we have it. So we have simple geocoding.tech now pointing to this IP address. So we don't have work with this IP address anymore. And now we can always check this simple geocoding.tech for any for the nominating geocoding API. So once this is live, once this is done, this will start working. Okay, so the next now is to set up the server that will be handling the SSL, but we also have to wait for this to come up live. But while that is working, we can actually create and connect to the server again using another part of the terminal, and we can SSH into the server. Okay, let me get the IP address of the server. Okay, I think this is almost finished. So now that we are back into the server, let's switch user to nominating, which is what we created earlier. And then let's go back to the home directory. Yeah. So one of the tools we're going to be using for this is Kadi. So Kadi is a reverse proxy tool that can also handle XSL certificates. So this is a documentation, which there you also see this code, which you can just copy and paste here. And of course, it's going to ask you for the password. It's going to install Kadi for you. So once Kadi is installed, we have already done this pointing of domain. So we can just run this command to enable firewall for Kadi. So once that is done, then you can also paste this command as well. And then when this is added, then we can now run the query to forward as to reverse proxy from our domain, which is simplegeocoding.tech. From simplegeocoding.tech to, so here you pointed to the local host where you have your server running. So which is port 9000 because of that's what Apache is using. But we can also confirm if this is even working already. So CAD is working, which is interesting. Let's just make it okay. It's actually working already. Interesting. So let me stop CAD. Okay, so CAD has been stopped. Let me run that reverse proxy command. So that's going to do the generation of SSL with latent scripts and everything like that. So once that is done, if I reload this, it should now have XXL certificates. So there's nothing at port 9000. So let's just confirm if this is working already by going to the raw IP address. Okay, it's not working yet. It's still. So that's the thing with the data you're trying to import. It can take a lot of time to import actually. Okay, I only have about 7 minutes more. Let's see. It's not done yet. So let me just go through the slides so you can see what you need to do to get this done. So once you are done with the whole system, assuming this has worked, you can just start using the API to search to query for address, right? And it's as easy as you go into the URL which you have deployed it, and then you put a question mark in front, and then /search, and then you can put your address to look up. So because the API or the data we imported is Monaco, so if I query this with Monaco, it's going to return a result. And that's assuming the deployment was successful, which is going to be if you follow this tutorial. But unfortunately, this is not up yet. So we just have to wait. Okay, it's worked. So I made a mistake earlier, and that was assigning port 9000 to the local host. Meanwhile, the port for Apache is 8080. It just occurred to me that Apache port is supposed to be 8080 and not 9000. So that was what caused the bug earlier. And after you're done with that, you can see everything is up. The geocoding is up. And when you query for an address, this is how you get a response from the API. It's going to return to you the bounding box of that address, the latitude, the longitude, the display name, and then the rank as well, and the importance. And then if it also matches another one, it's going to also return the other one as well, and then give you the rank for that as well, and then some other information about it. So as simple as that, you have your geocoding API live, And when you are done with that, if you are trying to bid for high traffic, then you need to know that you have to use a very high server and prepare to wait for number of days. And another thing is you can also customize this.
Referencing the same thing, no referencing.
Like you can provide an interval for it to update, because the data is coming from OSM, so you can always update it with live OSM data. So you can provide an interval for it to update. Say you want your API or your geocoding system to be updating every minute. You can also provide an interval here in milliseconds. Then you can also tune your database. You can customize it and everything like that. So it's on this documentation which you can also look into. So one of the shortcomings of this system is that, okay, so when you're done here, you can already leave you can close your server. Your server is already working and it's secured as well with firewall. So you're already done with your server. So one of the things that is one of the shortcomings of this platform is that it depends on OSM. So that means if your address is not on OSM, the geocoding will return a result. And a way to solve this is by you checking, say for example, someone searched for an address, just like the first address you tried on that geocoding platform where we couldn't get a result. One of the things you can do is to just go and map the address yourself, or better still, store it on your database. So you can have a database of addresses that returned 0 results from your geocoding system, and then you can find ways to update your DB with it. So because this is just a pure API, in the sense that if I give this API to you, you can use it. So no security, nothing. So it's always advisable to, have an API in front, which is more like another API, maybe written in Django, Node, or any other system. And then when someone query from Monaco, instead of going to this pure deployment, you go to your API, and then you can be able to handle stuff like authentication, tokens. You can even rate limit, in the sense that if someone is making multiple requests, after say about 500 requests per second, you can cut the request short. You can also profile your API. You can create documentation for your API. And you can also continuously improve your API. So you can say, for example, if the API is not coming with a token, you're going to return bad response. You can say, as you're hitting the API, the person will be charging some dollars from the person's account, right? So so that's the next steps. And thank you so much for attending. You can definitely connect with me on Twitter or LinkedIn in case you want to discuss about this further. And I really hope this has been helpful. And